Welcome to The Explainer. I am absolutely thrilled to have you here today. Look, we are going to completely dissect the highly sophisticated architecture of Datadome's 2026 bot detection system. We're going to pull back the curtain on this digital fortress and figure out exactly how modern bypasses actually work. If you've ever wondered what goes on behind the scenes when a website is trying to figure out, hey, is this a human or a script? Well, you are in for a real treat. Okay, let's dive into this. 10,000 plus. That number right there, that represents the massive scale of major websites currently protected by the Datadome Fortress. We're talking about giant global brands across e-commerce, media, travel, the whole shebang. Sites like Foot Locker, Hermes, and TripAdvisor literally rely on this exact system to guard their data and infrastructure. That is a colossal attack surface. And honestly, that's exactly why understanding this specific bot protection is an absolute necessity if you're a web scraping professional in 2026.
So think of this explainer as mapping out a digital heist. Here's our roadmap for the operation. First up, the Datadome bot fortress. Then we'll cover tripping the digital alarms, followed by the session cookie checkpoint. After that, we'll look at the anti-bot security landscape, map out the 2026 bypass blueprint, and wrap it all up with the browser isolation solution.
All right, kicking things off with part one, the Datadome bot fortress. Let's look at what makes this thing tick.
Under the hood, Datadome's architecture is, well, it's a really fascinating study in contrasts. On the client side, so running right there in your browser, it uses an intentionally lightweight JavaScript module. We're talking tiny, less than 30 kilobytes minified. It loads asynchronously in literally milliseconds, so it doesn't slow down the web page at all. But hey, do not let its size fool you. This little script is greedily collecting a massive amount of data about your device and your behavior and firing it all off to their API endpoint. But here is where the real heavy lifting happens, the server-side analysis engine. While the client script is tiny, this server-side engine is a blazing fast powerhouse. Every single request you make triggers a real-time evaluation, and get this, it completes its complex analysis in under 2 milliseconds. Just 2 milliseconds to make a definitive block or allow decision. That is incredibly fast.
Now, you might be wondering, how on earth is that 2-millisecond decision actually made? Well, Datadome uses a multi-dimensional machine learning pipeline. It doesn't just look at one single thing. Instead, it generates specific risk scores across 4 different dimensions: device trust, behavioral, network, and session. Then, these scores are all combined into one overall bot probability. Because it's multidimensional like this, a weakness in one area can actually be offset by a perfect score somewhere else. For instance, say you're connecting from a known data center IP, which definitely hurts your network score. The system might actually still let you through if your device trust and behavioral scores are absolutely flawless. It's this highly dynamic, constant balancing act.
Moving right along to part 2, tripping the digital alarms. Let's see what actually gets you caught. You can think of these as the security cameras and tripwires of the system. Datadome demands intense human traits. So if your bot moves its mouse in a mathematically perfect straight line or a perfect curve, alarm. If the mouse speed has a constant velocity, alarm. What if there's an absence of those tiny involuntary micro-movements we all make when hovering? Yep, alarm. And what about scrolling? Listen, if you scroll to the bottom of a page completely uniformly and instantly, that is a massive red flag. Humans pause. We read. We scroll up. We scroll down. And typing. Oh man. If your script types into a search box with perfect inner key timing and an instant key release cycle, you are caught for sure. The system rigorously checks for human typing errors and the natural messy variations in how long a key is held down. It is literally constantly searching for the chaos of genuine human behavior. And honestly, that brilliantly illustrates the next layer of the trap: device fingerprinting. Beyond just how you act, Datadome heavily scrutinizes what you claim to be. It's checking your navigator properties, your screen resolution, and really deep hardware markers like your WebGL renderer and audio context processing. It even creates a canvas hash. That's basically a unique fingerprint of how your specific GPU and operating system render an image. So why does all this matter? Because consistency is everything. If your user agent claims you're running Chrome on a Mac, but your canvas hash reveals a Linux rendering engine, or hey, you're missing specific macOS fonts, that inconsistency is going to instantly trigger an alarm. You can't just spoof a user agent string anymore, folks. The entire hardware profile has to match up perfectly. All right, that brings us to part 3, the session cookie checkpoint. So, The crucial point is really understanding this Datadome cookie. It is not just a simple tracker, it's an actual cryptographically signed session token. When you first hit a protected site, the server generates an initial cookie based on your IP and headers. Then the client-side JavaScript steps in, validates it with your behavioral data, and updates the token. Critically, and you really want to remember this cookie is strictly bound to your originating IP address, and it includes an expiration timestamp. If you try to switch a proxy IP right in the middle of a session, or if you submit an expired or forged cookie, the system is immediately dropping a capture challenge right in your path. It is a very tightly controlled checkpoint.
Let's zoom out a bit for part 4, the anti-bot security landscape.
When we compare the landscape, Datadome actually operates pretty uniquely compared to giants like Cloudflare and Akamai. Cloudflare and Akamai are heavily integrated directly into the content delivery network itself. They operate way out at the network edge. Datadome, on the other hand, is a SaaS module. It basically bolts right alongside existing web servers. And notice the JS payload size here. Datadome is incredibly lean, sitting at around 30 kilobytes. Meanwhile, Cloudflare's turnstile is well over 100 kilobytes, and Akamai is over 150. Also, while the CDN players process at the edge, Datadome relies entirely on that sub-2 millisecond server-side engine we talked about. Finally, look at the update cycle. Datadome updates its client scripts bi-weekly, so it sits right between Cloudflare's monthly updates and Akamai's highly aggressive weekly schedule.
So what does this all mean in practice?
It means Datadome has some very specific strengths and weaknesses. Where is it a bit easier to bypass? Well, it actually has less sophisticated TLS fingerprinting compared to an Akamai or a Cloudflare. Plus, that tiny 30 kilobyte script means there's a much smaller attack surface for you to worry about on the client side. And you've got a nice 2-week window between script updates to maintain your bypass. But where is Datadome harder? Oh, it is absolutely brutal when it comes to behavioral machine learning. Their behavioral models are widely considered to be best in class. Furthermore, because it's a SaaS model, if an IP or a behavioral pattern gets flagged on just one of their 10,000 customer sites, boom. That threat intelligence is instantly shared across their entire global network in real time.
Which leads us to part 5, the 2026 bypass blueprint.
Let's move to and see how this builds, because this is the master plan. Here is the exact 5-step blueprint you need to successfully infiltrate the system today. Step 1 is reconnaissance, checking the HTTP responses for the Datadome cookie and identifying the specific JavaScript source. Step 2 is browser setup, using stealth configurations to completely strip out all automation markers, like that pesky WebDriver flag. Step 3 is the behavioral layer, and guys, this is absolutely critical. You must program your automation to use natural Bezier curves from mouse movements, no straight lines, and implement variable speed scrolling. Step 4 is session management, utilizing sticky residential proxies so your IP doesn't suddenly change mid-session, and warming the session by visiting home pages first. And finally, step 5 is rate control, enforcing randomized human-like delays of anywhere from 5 to 30 seconds between your page loads.
Now, to actually make that blueprint work, you've got to satisfy these core requirements. And I really want to emphasize this point. Residential proxies alone will completely fail. Yes, of course you need sticky residential proxies that match your browser's configured time zone and language, but if you don't combine them with real browser automation, you're dead in the water. You absolutely must have perfect fingerprint consistency across your OS, your browser, and your hardware claims. And crucially, you need pre-warmed cookie jars. Look, if you just instantly hammer an API endpoint with a cold session and zero browsing history, Datadome's ML is going to assign you a massive risk score and block you immediately. You have to mimic a real, everyday user arriving naturally.
Finally, we arrive at part 6, the browser isolation solution. Managing all of those variables programmatically from scratch, it's incredibly difficult. That's where solutions like Send.win come into play, completely neutralizing Datadome's massive machine learning advantage by entirely changing the game. We're talking going from simulation to reality. Instead of using a script to just try and fake Bezier mouse curves or spoof a WebGL fingerprint, Send.win provides true cloud browser isolation. It runs actual, persistent cloud browsers in sandboxed environments. Because it's a real browser being controlled, every single mouse click, every scroll, every keystroke, and every single hardware fingerprint is 100% authentic. The behavioral data isn't simulated at all, it's genuine. So Datadome's ML models see these consistent fingerprints, real cookies, and authentic browsing history, and they just logically recognize it as legitimate human traffic. It really is a fascinating technological arms race, isn't it? On one side, Datadome builds this incredible sub-millisecond AI fortress to spot anything that isn't perfectly human. And in response, data extractors are leveraging true cloud isolation so that the bots aren't just mimicking humans anymore. They are literally using human tools in perfectly authentic ways. As ML bots learn to perfectly mimic human behavior, who wins the next round of this digital cat and mouse game? Thank you so much for joining me for this explainer, and I will catch you in the next analysis.